Hello everyone, welcome to another episode from Chedexcel. Today we are going to find oxidation numbers. Now this oxidation number comes under the part of redox chemistry, and that redox chemistry comes for unit 2 as well as unit 5. So unit 2, the third chapter is redox group 1, group 2 and group 7 chemistry. So I am going to start the basic from that chapter, but the very first part of this chapter is actually connected to the unit 5 as well. So we have something called oxidation numbers, that is what we are going to discuss today, and there is another thing called balancing redox reactions. So there it is connected to both AS and A2, that is in unit 5. So we will see what is redox reaction, what are the oxidation numbers, and today we will see how to find the oxidation numbers of a given substance. Now the oxidation number is something that is associated with an element depending on the way they react with each other. This oxidation number comes into the play because of the chemical reaction we have called redox reactions. So if you go back to that original word redox, this red means reduction and ox comes for the oxidation. We have this even for the IGCSE as well, redox reactions. So redox means a combination of reduction and oxidation. Now the terms reduction is specifically be given in terms of electrons and oxygen. So reduction is something called gaining electron, at the same time oxidation is losing electron, or we can say reduction is losing oxygen and oxidation is gaining oxygen. Other than electron and oxygen, we can use the word hydrogen as well to explain the reduction and oxidation, but commonly we are not getting it for redox titrations or the redox calculation. So I am not going to write it, but as we are doing it as a note, I am giving it here. So reduction is again gaining hydrogen and oxidation is losing hydrogen. So those are the three common way we can say either a reduction or an oxidation is taken place, right. So it depends on electrons, oxygen and hydrogen, we can explain the reduction or oxidation. Now the thing you have to remember is the neither oxidation nor reduction can happen by itself only. If there is a reduction, there should be an oxidation as well. In simple terms, if there is a reaction which gain electron, there should be a reaction which lose electrons as well. In the same reaction, there is a part of gaining oxygen, there should be a part losing oxygen as well. So reduction and oxidation, that is why we say combine in redox. This redox reaction cannot be taken place alone. If there is a reduction, there should be an oxidation as well in the same chemical reaction. So reduction and oxidation, simply we say like this, and if you take an example, very common example, I am writing it over here. Let us say Fe2O3 reacts with carbon monoxide to give Fe and carbon dioxide. This is a reaction that normally take place inside a blast furnace to prepare iron. So in this reaction, this is a redox reaction. It's a very common reaction that we always have written many times during O levels as well as A levels. So in this case you can see Fe2O3 has turns to Fe. So Fe has loosened oxygen. So losing oxygen. So this is a reduction, and you can see CO becomes CO2, which means it has gained oxygen. So this is oxidation. Now generally we use the term Fe2O3 has undergone reduction, carbon monoxide has undergone oxidation. Generally it is correct, but you have to remember the exact term we should use the oxidation or reduction for the element, not for a compound or a substance. The correct way is Fe has reduced, carbon is oxidized, or carbon has oxidized. Even though we say Fe2O3 is reduced, the correct one is Fe is reduced. Iron is the one which is reduced, carbon is the one which is get oxidized. So oxidation and reduction you can simply say for a compound as well, but the correct way is using it for an element. MCQs, they have asked, they have tested this in sometimes as well, so it should be referred to an element, right. The next thing is, when there is a reduction, I told there is an oxidation as well. When iron get reduced here, it makes carbon to get oxidized. So we say this whole compound Fe2O3, it helps carbon to get oxidized. So we say Fe2O3 can act as an oxidizing agent. Similarly, carbon gets oxidized, so carbon monoxide is the one which make iron to get reduced. So we say carbon monoxide is acting as a reducing agent. So simply the element which get oxidized tend to act as a reducing agent inside a compound. The element which undergo reduction tend to act as an oxidizing agent in a compound. So Fe2O3 act as an oxidizing agent, Fe undergo reduction. Carbon monoxide act as an reducing agent, carbon gets oxidized. So those are the common things that you should know at the beginning of this chapter. Actually this stuff you have in IGCSE as well, right. Now why do we need something called oxidation numbers is because there are chemical reactions that we can't exactly say whether it's an oxidation or a reduction by just looking at the chemical reaction. If we go to this example, MnO4 minus is a very common reaction, reacts with C2O4 2 minus, it gives Mn2 plus and carbon dioxide. Now in terms of electrons and oxygen, if we think which element undergo oxidation or which one undergo reduction, this one is little bit of confusion. For example, here let us say manganese, MnO4 minus to Mn2 plus, but oxygen has loosened, right. So we say loss of oxygen. So it's like in this case it's reduction, but the negative charge has become positive charge. When electrons are removing, it becomes positive, right. Negative charge to positive charge that means losing electron, so oxidation. So MnO4 minus, in this Mn looks like it has undergone reduction as well as oxidation, can't be only one is correct. If you come back to this one, C2O4 2 minus to CO2, loss of oxygen. So loss of oxygen means reduction. But again the same, you can see negative charge has neutralized, negative charge to 0 charge. Negative charge to 0 charge means it has loosened electrons, so looks like it's oxidation, which is impossible to happen in a same chemical reaction. You can't have two reductions or two oxidation at the same time. I mean, you can't have only oxidation or only reduction. Now in this particular case, it's really hard to see or tell in terms of oxygen and electrons that which element has undergo reduction and which element has undergo oxidation, because it looks like both are the same, or you can say both have undergo reduction, both have undergoes oxidation. So in a case like this, we can't exactly say which element has undergo reduction and oxidation. So we use a concept of oxidation numbers. So if the oxidation number increases the positive value, we say it's an oxidation. If the oxidation number decreases, we say it's a reduction. So we'll see how we can find the oxidation number, because in order to explain these reactions, we can't use the normal old method of definition we have used. So, to find the oxidation numbers, there are few basic rules. I will tell one by one. So, the first thing is oxidation number of an element is 0. Second one, the summation of oxidation numbers of a compound is also equal to 0. Third one, the summation of oxidation numbers of an ion is equal to the charge of the ion. Fourth one, the oxidation number of group 1 element is always plus 1. Oxidation number of group 2 element is always plus 2 in compounds. Then fifth one, oxygen is usually have the oxidation state of minus 2 usually. Sixth one, hydrogen is plus 1 with non-metals and minus 1 with metals. So, that is the sixth rule, and those are the 6 basic rules we use to find the oxidation numbers. So, having those rules in our mind, we can find the oxidation number of any given substance like this. So, let us start with the one I wrote, MnO4 minus. I am going to find the oxidation state of manganese. So, that is what I have to find. So, I put it as X plus oxygen usually minus 2. So, minus 2 into 4 is equal to the summation of oxidation numbers is equal to the charge of the ion. So, minus 1, X minus 8 equals minus 1, X equals plus 7. So, oxidation number of X, the manganese is plus 7. Now, remember, usually we always put the sign for the oxidation number. Rather than just writing X equals 7, we have to say X is plus 7, right. So, another one, C2O4 2 minus, those are the substances we had in that particular reaction. Now, we have 2 carbon atoms. So, it is 2X plus oxygen is minus 2 into 4 is equal to the charge minus 2. 2x minus 8 equals minus 2, x equals plus 3. So, oxidation state of carbon is plus 3, right. So, likewise we can find the oxidation state of any substance. Okay. So, if I do another example, okay, I will do it over here. Na2SO4. Let us say you are going to find the oxidation state of sulfur. Sodium is group 1 element always plus 1. So, plus 1 into 2, sulfur is the one we are going to find, X plus oxygen usually minus 2, minus 2 into 4 is equal to 0. So, you can find the oxidation number of X equals plus 6. So, oxidation state of sulfur in sodium sulfate is plus 6, right. So, that is how we can find the oxidation number of sulfur. Now, we can have oxidation numbers can either be positive, negative or fractions. For example, let us say we are going to find the oxidation number of ammonium NH4 plus nitrogen X plus hydrogen with non-metals plus 1. So, plus 1 into 4, that is equal to total charge is plus 1, x plus 4 equals plus 1, x equals minus 3. See, the oxidation state can either be negative as well. So, it can be positive, it can be negative, and not only that, the oxidation state can either be a fraction as well. There are compounds with the oxidation state is fractions. For example, let us find the oxidation number of another one. Let us say NaN3 sodium acide nitrogen. So, plus 1 into 1 plus 3x equal to 0. Summation of oxidation state is 0. You have 3 nitrogen. So, x equals here minus 1 over 3. See, the oxidation state of x is minus 1 over 3. So, likewise we can find the oxidation state of many different substances using the basic rules we have, right. If I use another one over here, H2O2 oxygen. Now, I told you usually oxygen is minus 2, but there are cases that it is not. Now, hydrogen with non-metal is plus 1. So, plus 1 into 2 plus 2x equals 0, x equals minus 1. So, in that particular case x is minus 1. So, using the basic rules I told you, we can easily find the oxidation state of any substance we have, right. So, that is how we find the oxidation state of different compounds. One last thing I will do, another common one we get is Cr2O7 2 minus dichromate ions chromium. So, 2x plus minus 2 into 7 equals minus 2, x equals plus 6. The oxidation state of chromium is plus 6. So, likewise we can find the oxidation state. If this oxidation, once you found the oxidation state, if the oxidation number gets increased, we can say it is an oxidation. If the oxidation number gets decreased, we say it is a reduction, and it is always true. So, we do not have to worry whether it is an oxidation or a reduction. No, if the oxidation number increases, so it is always an oxidation. If the oxidation number decreases, it is always a reduction, right. So, that is how we can easily find the oxidation state of an oxidation or a reduction, right. If we go to the previous example, right, that permanganate and carbon C2O4 2 minus, that example, we can find which element now undergoes oxidation and which element have undergone reduction using the formula we have using the normal way. So, we will see how to find the oxidation or reduction in that particular reaction. So, it is like this. So, if I use the same reaction again, MnO4 minus plus C2O4 2 minus gives you Mn2 plus carbon dioxide. So, I found the oxidation numbers in the previous case. Manganese, you can find it becomes plus 7, carbon becomes plus 3 here, plus 2, plus 4, plus 7 to plus 2. Manganese is the one that actually undergo reduction, plus 3 to plus 4. So, this is the oxidation. Now, we can easily say which element has undergone oxidation and which element has undergone reduction, right. So, that is how we find the oxidation numbers, and the next video we will see how we can use these oxidation numbers to write the balanced redox reactions. It is another part we will discuss in another video. So, if this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.